on solution stoichiometry. And backing up, you can see I fixed this slide, but the answer came out the same. So I did fix the slide, and I apologize for the error. Let's just kind of quickly go through here. All right, so solution stoichiometry, it's just stoichiometry. It's just using solutions to get to moles. And just remember that molarity times volume is moles. I'm just going to go through 3 examples here. All right. So you might want to review the stoichiometry slides, because all stoichiometry is basically a variation on the theme, get to moles of one thing, right? Get on the mole highway. Use the balanced chemical equation, the mole highway, to get to the moles of what you're asked about, and then get out of moles. And right now you have 3 different ways to get into moles and 3 different ways to get out of moles. And these are the 3 different ways: using molar mass to go to and from mass, using Avogadro's number to go to and from particles, which would be atoms or molecules, and using molarity and volume. All right, and I'm going to try to mix it up. Homework 11 has a lot of this. That's what homework 11 is. All right, so let's go through this one. We'll just do a couple examples. How much 0.125 molar sodium hydroxide solution do you need to completely neutralize 0.225 liters of 0.175 molar sulfuric acid? So neutralize just means reacts with. It's just another word, right? So hit pause in between. Try each step on your own. So the balanced chemical equation. And there it is. And then a good habit is write the information about each thing underneath. So in this case, we have 2.225 liters and 0.175 molar. We have 0.125 molar, and we're trying to find the volume. So then stepwise, a good first step, right down. So you're going to get on the mole highway, in this case here. Take the mole highway to sodium hydroxide and get off. So again, reviewing the slides on stoichiometry can be very helpful. So there's my units. So once again, where do I have liters of sodium hydroxide? All right, I'm going to do this slowly so you can hit pause. That's where I have liters of sodium hydroxide in the molarity. All right, now I have to make moles of sodium hydroxide go away, but we have to get to moles somehow. All right, so I'm literally just counting to 5 in between when I tell you to hit pause. So hit pause, try it on your own. All right, so what I did is I said, okay, well, I'm not really sure what step here, but I can get to moles. I know I can get to moles using the molarity and the volume. So that gets me to moles. Now I have moles of sulfuric acid and moles of sodium hydroxide here. And how do I make them cancel? That's where I use the balanced chemical equation. And there you go. All right, so that's basically the approach. Everything is just a variation on this theme, and you can see this is exactly what we did with regular stoichiometry. We did all sorts of stuff. Right? Exactly what we did. Try this one on your own. How many grams of silver chloride will be precipitated or formed by adding enough silver nitrate to react with 1,500 mils of 0.4 molar barium chloride? So first step is write the balanced equation. And there it is. And I went as far as, so barium chloride reacting with silver nitrate. All right. I went as far as to write down the information. I converted this to liters and where I'm going. So here I'm going to get to moles here. I'm going to go to moles there and get off of moles. No matter how you're doing this, if you're going forwards or backwards, the first step should be write the units of the answer. There's the units of your answer. We want grams of silver chloride. And again, because so many people solve the wrong problem. They do everything right, but they solve for the wrong thing. So if you write down, just like taking a trip, if you just start randomly driving, you're going to get somewhere, but you want to get to Wally World, right? And so you want to find out where Wally World is. All right, so let's do this one kind of going forward. So how am I going to get to moles? Well, I can use the molarity and volume of the barium chloride, right, to get to moles. So now I'm in moles of barium chloride. Still want to get to grams, but down here, I'm on the mole highway. The next step is, let's see if we can get the units of the answer, right? Grams of silver chloride. So I have moles of silver chloride here, the right unit in the right place, but I have moles of silver chloride here, moles of barium chloride here, and again, I'm going to say this for the 863rd time. We want, don't just write moles, but moles of what? Right, so this step should have what on the top and what on the bottom. Okay. That would be the last step, and you can see how everything cancels out nice and pretty. And if you didn't do this, you might not know that you need to use that too right there. Okay? And don't forget about significant figures. All right, there's only one more. Try this one on your own. Give yourself a few minutes. Okay, I'm going to walk through it. How many hydrogen molecules will be formed from the reaction? All right, so this one's a little bit different. Let's write out the balanced equation. And let's write the information about each thing by that substance. So these steps are extremely helpful. Right? I have 1.65 grams of aluminum. For the hydrochloric acid, I have 0.25 molar and that many liters. And I want to find molecules of the hydrogen. So what type of problem is this? When you have starting materials? You guessed it. It's a limiting reactant problem. Fun with limiting reactants. So we're going to go through how to solve this on the next slide. It's the last slide. All right, so remember for limiting reactants, set up what you have and what you need. So just try this on your own. Hit pause, and then go through as far as you can, and then I'm going to go slowly through each step, and you can hit pause kind of on your own. And my phone rings. All right, so the first thing we want to do is find out how many moles of each thing that you have. So we used, in this case, we used the mass and the molar mass for the aluminum to get the moles, and we use the molarity and volume of the hydrochloric acid. And how do you know how to get to moles? You look at the information you have. And if you recall, the next step is pick one reactant. It doesn't matter which, but here's how many moles of each I have. Use the balanced equation to find out how many moles of the other that you need. So I chose the aluminum, and you can see that from the balanced equation, 6 moles of hydrochloric acid for 2 moles of aluminum. That means I would need 0.183 moles of hydrochloric acid if I'm going to use up all the aluminum. You can see that I have more than that. That means that the hydrochloric acid is in excess. Because I have 188, I only need 183. It's close here, but I still have excess. That means the aluminum is the limiting reactant. So if you remember then, the last few steps is we start with our moles of limiting reactant, and we want to find molecules of hydrogen. So we haven't answered the question yet. So we're going to start with the moles of aluminum. So I just took that and I put it right here. And the hydrogen, right? And then we're just going to play with steps. You can go forwards, you can go backwards. I always try to get that unit at the end, so I know I can get molecules using Avogadro's number. And now I have moles of aluminum and moles of hydrogen. And the balanced equation, 3 moles of hydrogen for every 2 moles of aluminum. So I put that step in, and that should do it. All right. So it's really important that you make, I love how my phone rang. I have all day long, the phone doesn't ring, right? Anyway, so again, you want to have a step-by-step approach to doing this step, just like everything we've done all semester. Go step by step. Make yourself go step by step. Be diligent about labeling your units, because there's a lot of steps. If you get a little sloppy or if you go a little too fast, it's very easy to make mistakes just by writing something down wrong. That's it for this set of slides.